Welcome to my last video on circle theorems. So as we are going through this video, I am hoping that you've watched the first 3 videos on circle theorems because we are going to apply that knowledge into solving these questions. Now, in this video, our main concern will be giving the solutions as well as the reasons for our answer. Okay, so let's go straight to solving the problem. There is a figure on the screen there, question number 5. And they're saying center of that circle is O, right? That is very important because once you see O and there are lines joining O to the circumference of the circle, we know that those lines are equal because they are radii. So now they want you to calculate the angle CBD. So let's look at CBD. CBD is right there, okay? If you look at CBD, the angle at B, together with the angle at O, they are all subtended by CD, all right? So CD is subtending angle O at the center. It's also subtending angle B at the circumference, okay? So that simply means that angle at B is 124 divided by 2, all right? Which will give us 62. So 62 is our answer for CBD, all right? Let me just label it there. And the reason is angle at the center is twice the angle at the circumference. All right, that's our reason for this answer. So let's see. They're saying work out angle BAD, that is Roman 2. Let me just get myself a different color of pen for that. Angle BAD. So if you check angle BAD, BAD is there, the angle at A, okay? So this calls for the theorem of cyclic quadrilaterals, all right? Because angle A and angle C, by angle C, I mean the whole C, all right? The whole C there and angle A are opposite angles inside the cyclic quadrilateral. In this case, our cyclic quadrilateral is ABCD, all right? So now, the only thing we are missing is this angle right here next to 35 degrees. And that one we can get because triangle ODC, see this triangle here? It's isosceles triangle, okay? ODC is an isosceles triangle because it has 2 lines equal. So that means the angle next to 35 there and the angle up here at D are equal. So what we need to do is just take the total sum of angles in a triangle, subtract the 124 given there. All right. What do you get when you subtract 124 from 180 degrees? Let me just do that in my calculator. You get 56, okay? So 56 degrees is the angles remaining for that triangle OCD. Now what we do with 56, we divide it by 2 to get 28 there. That is 28, and this one down here is 28. All right, so up to that point, we have the whole of angle C. So angle C is actually 35 plus 28, okay? So what do you get when you add 35 and 28? You get 63 degrees. So angle C is 63 degrees. So now angle C and angle A are opposite inside the cyclic quadrilateral. That means the 2 of them should add up to 180, all right? So angle A we get by subtracting angle C from 180 degrees, and we'll end up with 117. So 117 is our answer up there. And our reason would be opposite angles in a cyclic quad are supplementary, okay? Opposite angles in a cyclic quadrilateral are supplementary. all right? And the first answer there, 63, you were able to get it using which reason? Base angles of isosceles triangle, okay? So we use the knowledge of isosceles triangle to get angle C. So once you give an angle together with the reason for your answer, you'll be able to get all the 2 marks, all right? Let's look at another question. Just clear all this. So there's another question here, question 2, all right? So hopefully you can see question 2. Question 2 says, A, P, B are points on the circle, center O. So the word center O there is key, right? Because it helps us to identify the radii. So now that O is the center, means that's a radius and that's a radius. So we have an isosceles triangle. That means the angle at A, the whole of that angle at A there is 38, okay? Because for isosceles triangle, the base angles are equal, all right? So that means we can get the angle at O. Inside that triangle, we have triangle ABO. Let me just sketch it here. Sorry, that is A. This is B. That's O. Now this is 38. And this 38, okay? So you can get the missing angle at the center there by taking the angle sum of a triangle, so which is 180. So we'll take 180, subtract 38, subtract another 38. What do we get when you subtract both of those? So minus 38 minus 38, you get 104, okay? So our angle at O here, sorry, it's 104 degrees. So now, once we have angle at O, look at AB. AB is making angle O at the center. Again, AB is making angle P at the circumference. So using the theorem of angle at the center and angle at the circumference, we can get angle P by simply doing half of angle at the center, okay? So 104 divided by 2, all right? That will give us the answer, which is 52 degrees. Suppose this question asked for a reason. Now remember this question, first of all, guys, it's 3 marks, okay? So all this working, all these, you might just want to include them in this space left, okay? Because they'll all be marking points, all right? So the reason for this answer would be angle at the circumference is half angle at the center, or the reverse of it, which means, which says angle at the center is twice angle at the circumference, all right? Let's move on to part B of the question. Let me just clear all that. So part B of this question, there's a quadrilateral and it's a cyclic quadrilateral, right? So the cyclic quadrilateral is, let me just see the letters well, CDEF, okay? CDEF, sorry, is a cyclic quadrilateral. Another important thing you can note is that this line and this line are equal as denoted by those marks on them. So because they're equal, it simply means this angle and this angle are the same, all right? Because FCE is now isosceles triangle. Isosceles triangle, we know the base angles are the same. Okay, so angle at C there and at E there marked in red are equal simply because the 2 lines there are the same, are equal in length, okay? So now, angle E, we are able to find it by using the alternate segment theorem, okay? So alternate segment theorem states that, sorry, need to have a good line. If you have a tangent there meeting with a chord at some angle, then that angle should be equal to the angle made by that same chord in the alternate segment, okay? So the angle that this chord will make here is the same as this angle it makes with the tangent. So the angle marked in red for E is actually 50 degrees, okay? Because of this one down there. So now, what do? The isosceles triangle It simply means if that's 50, then this also 50 because of base angles of isosceles triangle. Okay, so that means you can get the angle at F, which is what they want, EFC. So the angle at F, we use rules of a triangle, right? Angle sum of a triangle add up to 180. So we're going to do 180 degrees minus 50 minus 50, okay? That's total of 100 subtracted, so we end up with 80 degrees. Okay, now remember guys, I'll be pasting the link to the first 3 videos of this series just in the video description below so that you can watch those videos for you to understand better. Okay, so let's move to the next part. Roman 2. Roman 2 wants angle CDE. Where is CDE? CDE is this angle here, inside here. So angle D inside that triangle, okay? The one I've marked in blue. So now to get that angle, we know that F we have found to be 80 degrees, all right? So now we apply the knowledge of cyclic quadrilateral. The opposite angles in a cyclic quadrilateral are supplementary, all right? So supplementary angles are angles that add up to 180. That means if you take angle F plus angle D, because they are the opposite angles we are talking about, we should get 180 degrees, all right? So that means if you want D, F will cross to the other side, okay? So F was positive, now on the other side to be subtracted. That means angle at D is the same as 180 minus 100. No, minus 80, sorry, because F is 80. And you'll get your angle D to be 100 degrees. Okay, so that's it, guys. I hope you've learned something, and I hope you'll be able to handle such questions in an exam situation. All right. Thank you very much for watching my videos. Thank you for your subscriptions. I'm very grateful.
Audio Jungle.